continue on talking about segments and rays, and we're going to make compound segments put together, and to put rays together to make angles. So the first thing I want to talk about is how to know two segments are congruent. And the construction part we're going to do later on, because you have a test on, or a quiz on Friday over this stuff, and I want to make sure we're ready. So we'll do the constructions afterward. But first thing you want to do is, well, there's a couple ways you can do it. One is you can measure it with a ruler, or you can construct it yourself. Again, we're going to do the construction later. But let's talk about what makes a segment congruent, or looking at it, because in geometry you talk about pictures and you talk about numbers, and we kind of do them side by side. But if we're talking about pictures, like in this example here, the segment AB is congruent to the segment QR. We're talking about pictures, all right? If I want to say the length of segment AB is equal to the length of QR, I would write it like this. So write this in your notes. The segments or pictures are congruent and measurement is equal. Pictures are congruent, measurements are equal. All right? And if we want to prove that, or if you want to show that two segments are congruent, we would put these little tick marks there. So for instance, what kind of triangle is this? Right, it's an equilateral triangle because all the sides are equal. We showed that by putting these tick marks in. All right, so, okay, so we're going to talk about the betweens principle, and that is, we talked about that, remember, on your preview questions, like what is between? Well, in mathematics, we say if AB here plus BC is equal to AC, then B must be between A and C. Because think about if B were over here, then AB plus BC would not equal AC, for sure, because it's way too long. So between is defined by the fact that we can add these two pieces together and get that big one. All right, and it works the other way too. If B is between A and C, then AB plus BC equals AC. All right. So let's put numbers to that. Like, let's say I told you that AC was 27 and AB was 11. What is BC? Well, BC would be if AC, the whole thing, is 27, and just the AB part is 11, what would BC be? AB plus BC equals AC. We know AB is 11. We know AC is 27. We don't know BC, so we would solve by, right, subtracting 11. So we would subtract 11 and we get 16. BC is 16. So that's just with numbers. But if we were going to have some real fun and put it with equations, okay, like instead of just saying that mn is a number, we're going to say mn is an equation, 2x plus 6. So mn is 2x plus 6, and p is 4x minus 3, and mp, the whole thing, is 5x plus 12. So again, we know, because n is between m and p, we know that mn plus np is equal to mp. So then I just fill in, instead of numbers, I'm going to fill in equations. So 2x plus 6 plus 4x minus 3 is equal to 5x plus 12. And then I have to solve it, okay? And I'm going to solve it by combining like terms, making that 6x plus 3 equals 5x plus 12. Subtracting 5x from both sides, subtracting 3 from both sides, and I get x is equal to 9. Now that's not giving me mn and p or mp, that's just giving me x. To find mn, I would plug it in. So mn, the length of mn, it would be 2 times 9 plus 6. And that's 18 plus 6, 24. NP is 4 times 9 minus 3. So 36 minus 3 is 33. And two ways I could do, I could plug in 9 again and get 5 times 9 plus 12, which is 57. Or, because I know that these two added together should give me this one, I can just add them together and get 57. Okay, so that's one way that the segment addition postulate, which is the between principle, is applied. Another way is, let's say S is not only between R and T, but it's exactly in the middle. So that means RS is exactly equal to ST. So if RS is 4x minus 7, and ST is 5x minus 15, and S is exact midpoint, it's exactly in the middle, then they're equal. And so I solve and I get x is equal to 8. And again, plug in 4 times 8 minus 7 is 32 minus 7, which is 25. And because it's a midpoint, if RS is 25, then ST also has to be 25. And the two of them together make RT, which would be 50. All right? That's segment addition. Now, if we talk about angles, angles are two rays put together, joined at their end point. So this is ray BC and ray BA put together to make an angle, and it makes angle ABC. And what do we have to remember about angles? Right, you have to put the vertex, the corner here, has to be in the middle. So this could be either angle ABC or angle CBA, doesn't matter, as long as B is in the middle. All right, now we've already covered acute, right, obtuse, and straight. We've covered how to measure an angle. Just like tick marks tell that segments are congruent, these little arc marks tell that angles are congruent. So if you see those little marks on two angles, it's telling you, hey, these angles have the same measure. Okay, now let's talk a little bit about the angle addition postulate. It works just like the segment addition postulate. Remember, it says if we had a point in between, this plus this equals this whole thing. Well, the angle addition postulate says that this angle plus this angle equals the whole angle. So if I were going to write it out, it would be angle PQS plus angle SQR is congruent to angle PQR. Okay? Now, if I wanted to talk about equality, like the actual measurements, I would use an M for measure. The measure of angle PQS plus the measure of angle SQR is equal to the measure of angle PQR. Okay? The two pieces, just like segment addition, the two pieces of the angle equal the whole angle. Okay? And couple ways we can do it. One is, like, let's do this one down here first. AOB, it's good to visualize it, trace it with your pencil, is 4x minus 2. BOC is 5x plus 10. And AOC, this whole thing, is 2 times 6x minus 8. Okay, so the angle addition postulate says this one plus this one equals the whole thing. So I can write 4x minus 2 plus 5x plus 10 equals 2 times 6x minus 8. And, work this equation, combine like terms. So I get 9x plus 8 distribute equals 12x minus 16. Add 16 to both sides, subtract 9 from both sides. And I get 24 is equal to 3x divided by 3. And I get x is 8. Okay? Now for this one, it's a little different. Same picture, but it says that AOC is 7x minus 2. It says that DOC is 2x plus 8. And it says that EOD is 27. Well, I can't use the angle addition postulate exactly because I don't know what these two pieces equal to be able to solve it. But I do know that if I put all three of these angles together, it equals 180 because AOE is a straight angle, so it's equal to 180 degrees. So because I know that, I can say that 7x minus 2 plus 2x plus 8 plus 27 is equal to 180. And then I can solve it. So 9x plus 33 equals 180. Subtract 33 from both sides and get 9x equals 147. Divide by 9. 9 goes into 14 once. that leaves 5. 9 goes into 57 6 times with 3 left over. So it's 16 and 3/9 or 16 and 1/3. Okay? So that is different ways you can use the angle addition postulate.